Hello students, in this video lecture, we will solve some problems. In the previous video lecture, we solved some problems on second formula for Fourier series, which satisfies the condition neither even nor odd. Did you remember that problem? Yes, it is f of x equals to x plus x square. Now, we are going to do problems on conditions even and odd. Before going to that, please pause the video, note down these formulas again, then we'll start the class. Okay? Read the problem. Express following function as Fourier series in the interval minus pi comma plus pi. F of x equals to sin ax, where a is not an integer. Okay. Now, what was given? Given a function f of x equals to sin ax. And also they mentioned the interval minus pi comma plus pi. So, which formula we have to use? Yes, the second formula. So, while solving this one, we have to check whether the given function is even or odd. Let us see that. Given f of x equals to sin ax. Replace x with minus x. What you got? Sin minus ax. We know that sin minus theta equals to minus sin theta. So, this can be written as minus sin ax. This equals to, using 1, we get minus f of x. So, what you got? F of minus x equals to minus f of x. This is nothing but the condition for odd function. So, our function f of x equals to sin ax is an odd function. Draw a line like this in your notes. Note down in this manner. Okay. Now, solution. Given function f of x equals to sin ax, where a is not an integer. We already solved that the given function sin ax is an odd function. So, it is an odd function. What it is? It is an odd function. If it is an odd function, then the Fourier series expansion will turn it as the Fourier series expansion for f of x equals to sin ax in the interval minus pi comma plus pi is given by sin ax equals to, since it is an odd function, in your Fourier series expansion, the cosine terms will vanish. Nothing but a not equal to 0 and an equal to 0. So, in your expansion, we get sin ax equals to sigma n equals to 1 to infinity bn sin nx. Okay. Let it will be equation 1. To find this bn value, write down the formula first. What is your Bn formula? Yes, Bn equals to 2 by pi integral 0 to pi f of x sin nx dx. Now you have to substitute f of x equals to sin ax in this formula. Before going to that, note down this equation 1 here in this column. To find Bn equal to 2 by pi integral 0 to pi f of x sin nx dx. Before evaluating the integral, we will just recall some formulas. Okay. What is sin n pi if n is an integer? Yes, 0. What is the formula? 2 sin A sin B. Yes, cos A minus B minus cos A plus B. And one more formula. What is sine of A plus B and what is sine of A minus B? Sine A minus B equal to sine A cos B minus cos A sin B. Sine A plus B equals to sine A cos B plus cos A sin B. Okay, we will use these formulas while evaluating the integral. Now, what is your Bn? Bn equals to 2 by pi integral 0 to pi f of x is sin ax into sin nx dx. This can also be written as 1 by pi integral 0 to pi 2 sin ax sin nx dx. Now, which formula we will use? Yes, this one. This is of the form 2 sin A sin B. Here A is Ax and B is Nx. This can be written as 1 by pi integral 0 to pi cos Ax minus Nx minus cos Ax plus Nx into dx. This equal to 1 by pi integral 0 to pi cos A minus n into x minus cos A plus n into x dx. This equals to 1 by pi. What is integration of cos? Sine. So, this value will be written as sine A minus n into x by A minus n minus, for this, sine A plus n into x by A plus n over the limits 0 to pi. Now, substitute the upper limit and lower limit. What we got? This equals to 1 by pi, substituting the upper limit, sine A minus n into pi by a minus n minus sine a plus n into pi by plus n minus substituting the lower limit sine 0 by a minus n. You know that sine 0 equals to 0. So, this part will be equal to 0 and similarly this will also be get sine 0 by a plus n. This equals to 1 by pi sine a minus n into pi by a minus n minus sine a plus n into pi by a plus n. Now, it remains to calculate what is sine a minus n into pi and what is sine a plus n into pi. Let us see that. Sine a minus n into pi can be written as sine a pi minus n pi. This is a and this is b. So, we have to use this formula. This equals to sine a pi cos n pi minus cos a pi sin n pi. As we know that sin n pi equal to 0 and what is cos n pi? Minus 1 power n. So, this will be equals to sin a pi into cos n pi minus 0. This equals to sin a pi into minus 1 power n. What it is? This is sin a minus n into pi. What you got? You got sin a minus n into pi by a minus n as minus 1 power n sin a pi. Similarly, we will calculate sin a plus n into pi by a plus n. So, first let us see what is sin a plus n into pi. This equal to sin a pi plus n pi. This can be written as sin a pi cos n pi plus cos a pi sin n pi. So, what you got? This is nothing but this part is 0 and we got minus 1 power n sin a pi. Now, substituting these two values, here, 1 by pi minus 1 power n sin a pi by a minus n minus second value minus 1 power n sin a pi by a plus n. This equal to, take common this value, minus 1 whole power n into sin a pi by pi into 1 by a minus n minus 1 by a plus n. This equals to minus 1 whole power n sin a pi by pi into this equals to minus 1 power n sine a pi by pi into plus a and minus a get cancelled. We get 2n by a square minus n square. This can also be written as minus 1. Take common minus here. We get minus 1 power n plus 1 sine a pi by pi into n square minus a square into 2n. Okay, minus 1 power n sine a pi by pi into 2n by a square minus n square can be written as 2 into minus 1 power n plus 1 n into sine a pi by pi into n square minus a square. Here n square minus a square not equals to 0. Now, this is our Bn value. Substituting this Bn value in equation 1, we get sin Ax equals to sigma n equals to 1 to infinity 2 minus 1 power n plus 1 n into sine a pi by pi into n square minus a square into sine nx, which is our required Fourier series expansion. Now, expanding the summation, we get sin Ax equals to, put n equals to 1 in this expression, we get 2 minus 1 power 1 plus 1, 1 into sine a pi into sine 1x by pi into 1 square minus a square plus second term 2 into, put n equals to 2 here, 2 into minus 1 power 2 plus 1, 2 sine a pi sine 2x by pi into 2 square minus a square plus so on. This can be written as 2 sine a pi into sin x by pi into 1 square minus a square minus 1 whole cube, nothing but minus 2 into 2 sine a pi sine 2x by pi into 2 square minus a square plus so on. This can be simplified as taking common 2 sine a pi throughout, we get 2 sine a pi by pi, we get sine x by 1 square minus a square minus 2 sine 2x by 2 square minus a square plus, what will be your next term? 3 sine 3x by 3 square minus a square, and so on. Is the Fourier series expansion for f of x equals to sine ax in the interval minus pi comma plus pi. Is it clear? Note. Here in the denominator part, all values 1 square minus a square, 2 square minus a square, the coming values 3 square minus a square will not become 0. Okay, observe this problem. So far we are discussing Fourier series first formula and Fourier series second formula. Which formula is to be used to solve this problem? Yes, Fourier series second formula. How did you identify that one? By observing the interval. This is the direct way of asking the question. Sometimes it will ask in a different manner. At the same time, we can find the function f of x directly in the problem. That is also given in an indirect manner. I will show that also. In model 2, what are the intervals? Yes, here also minus pi and plus pi. That means the interval is given indirectly. X lies between minus pi and plus pi. That means our interval minus pi comma plus pi is given. And what is your function f of x? Yes, clearly sine ax. So the function also given indirectly. Now see. What happens if this sine a pi comes in this side? Yes, 1 by sine a pi. Nothing but cosecant a pi. Observe this one. Sine ax cosecant a pi. The remaining series is same. That means model 2 can also be given like this. Here the function f of x is given directly. Interval is also mentioned directly, but they concentrated on the coefficient cosecant a pi. That means sine a pi turned it as cosecant a pi. Did you observe the change? In this way, they will give you model 2 as model 3. Is it clear? I will give you some practice problems at the last slide. Please practice it well. We'll do the next problems in the next session. Thanks for watching till the end.